part 3, we'll be talking about what's wrong with induction. So David says he has 2 main points about what's wrong with it beyond what was discussed before, and he says these are more important. The first one is induction is about predictions about experiences, but science is not about experiences of human beings primarily. Science is about reality, what is in reality. It's about physical objects, like balls and rocks and stars, hills and planets and black holes, and photons. Science only makes predictions about human observations indirectly. First, it comes up with a model of the world. How does a photon work? What trajectory will a rock or an asteroid go in? Stuff like that. And then when you're modeling the external world, you can come up with, this is going to be at a certain place at a certain time. Therefore, if I look at that place with the telescope or whatever, then I'll see it. And if I look somewhere else, I'll see empty space. So experiences or observations are a bit secondary in science, because the main thing is to model reality. David also says it in terms of our predictions of how things will look are deduced from explanations of how things are. So the key thing is, what is it, how does it work, etc. And then you can figure out how will it look or smell or sound, these measurable observations, based on what it is in the underlying physics. So induction is looking in the wrong place with this focus on predicting human experiences or observations. All right, second point. Induction says the future will resemble the past, or the seen resemble the unseen, or something along those lines. But change is common. David says, in reality, the future is unlike the past. We often predict things that are new and different. For example, we predicted that we could fly, and before we had ever experienced flight in an airplane, we predicted what an atomic bomb explosion would be like before we had ever set one off. So we weren't basing that on our past experience in any kind of direct, straightforward way. David gives another example. For sunrises, they're different in orbit, and we knew that before we'd ever gone to orbit and experienced that. So the 2 big misconceptions, one is the focus on human experience instead of external reality. The other is, how do you predict things that are different than the past or the near or the seen or the experienced? Induction doesn't have a good answer to that. All right, next part. David is trying to talk about proposing laws of nature. And he says, for any law of nature, in some sense, you're saying the future resembles the past, because in the past, the law of nature is true, and in the future, the law of nature is true. So it's the same in some sense. But that's useless for figuring out which laws of nature are correct. It doesn't help you pick one law of nature over a different one, so it doesn't give you any meaningful guidance. So a principle like the future resembles the past, if you use it in that way, it's not useful. The reason David brings up this way of using it is this is at least correct. Whereas when you just say the future resembles the past in general, in ways other than has the same laws of physics, then you tend to be wrong because change is common. And David goes through some examples of how things change. So, for example, he experienced the year starting with a 1 and then a 9 over and over and over again, yet he was able to predict in advance that things would change contrary to his experience, and that in the future, the year would start with a 2, which happened when the year 2000 came along. He goes into another example about sunrise. Often, you cannot see the sunrise due to clouds in the way. Does that mean the sunrise didn't happen that day? It doesn't, but how do you know that? It's not just that you don't just observe the sunrise every day and see a pattern. Sometimes you observe clouds instead, and you need to have some sort of model of reality to understand what clouds are and how they can block your view of the sun, and that the sun is still there even though you can't see it, and so on. Induction is not good at explaining things like, I can't see it, but I know it's there, because it's so focused on what you can and do see. So, more generally, what counts as a repetition of a phenomenon depends on theory. It depends on interpretation and explanation. It's the same issue as what counts as the same thing or what counts as similar. A repetition has to either be the same or sufficiently similar. So similar in what ways? There are infinitely many different ways you could judge similarity. So what we view as repeated, as a repetition or a pattern or anything, is based on our theories, our explanations, our scientific understanding. It can't be the starting point for our learning. It has to come later when we already know something. But induction is supposed to be a very general, fundamental theory about how learning and thinking and intelligence work. It's supposed to explain those things, not be a secondary consequence where first we're intelligent in some other way and then that lets us do induction. It's supposed to come first, not later. The starting point problem, like where does intelligence come from, how can it work, is the harder problem. That's what people wanted to know, is how can we learn anything? Not assuming that we can learn things. Try to say, use your intelligence to figure out what's repeated and which patterns are important, and then whatever patterns are important, say that you've inductively deduced it and that it's important. Like you already know it's important from something else prior, so induction isn't adding anything or helping. So David then moves on. He says, so much for inductivism. I think it's a difficult topic, so I'm going to do more on induction in the next video as well. This comic from XKCD helps make it more intuitive and easy to understand that patterns often break, with a large number of examples. So the examples are all from US presidential elections. So in 1788, there's a pattern. No one has been elected president before, which broke. And then in 1812, no one can win without New York, was a pattern that had persisted up until that time, and then it broke. In 1816, the pattern that only people who wear a wig get elected was broken. There are so many different patterns in the world, and the hard part that I think inductivists overlook a lot is figuring out which patterns are important and why. You can't just look for patterns, you have to look for important patterns, meaningful patterns, which patterns matter. It's the same thing with the future will resemble the past. It always, no matter what happens, the future will resemble the past in some ways and not others. And the important, more difficult thing is figuring out which ways the future will resemble the past, rather than just saying it does or doesn't. So up until 1884, presidential candidates named James never lost, but then a guy named James went ahead and lost. No Republican who hasn't served in the military has won until 1908, but then one did. Catholics can't win until 1960, and then they did. Anyone who won Louisiana won the presidential election until Goldwater. And at the very end, it says a streak has to break. He gives two different streaks, then one of them was going to break in 2012. Either Democratic incumbents never beat taller challengers had to break, or no nominee whose first name contains a K has lost. One of those has to break. So always, no matter what happens, some patterns break and some continue. Technically, there are infinitely many patterns that break and continue for every single event. And understanding which patterns are actually important and meaningful rather than local and parochial, as David puts it, it's tricky, it's a big deal, and induction doesn't offer any help with that problem. It has no useful advice about how to do that. So David's next main point is that explaining reality takes creativity. There's no mechanical process where you just look at things and know what's going on. When you look at the sky, you see dots. And understanding stars is a different thing than just observing. Or just looking for patterns in the dots you observe isn't going to tell you what stars are. So instead of deriving correct answers from data, we have to brainstorm guesses, which could be mistaken, and then we improve them using criticism and scientific tests. David's talking about that here. I'm trying to pick which parts I think are important and focus on them and try to make them extra clear. So the key idea is progress. When it comes to ideas, instead of having the right starting point, like we induced a good theory, what we need to do is recognize no matter how we come up with our ideas, they might be wrong or bad or dumb. There's no way to make our brainstorming and guessing process ever reliable. So what we really need to focus on is how do we make our ideas better? How do we make progress? This is the same insight that Karl Popper had. I think it's mentioned later in the book about the who should rule problem. He says instead of figuring out who should rule a society, like, the important thing is how do we get rid of bad leaders? How do we make progress? How do we correct errors? That's an ongoing theme of David's work. That it's more important to be able to correct errors than to start in a good starting point. The journey and the progress are more important than where you are right now. So that's another thing that induction doesn't really talk about, is how do you take an idea that you've already induced and then improve it? How do you make further progress? Critical discussion is an answer to how to do that. So here, David talks about observing the sky and how people observed it a lot and they thought that their beliefs were confirmed over and over again. So following the inductive method, they became very, very confident, but then they were wrong. In some ways, for example, people thought that the Earth was the center of the universe. Turned out the sun was the center of the solar system and not even the whole universe. So our senses don't tell us how to interpret things. We have to think and use intelligence and creativity. And we shouldn't treat our senses or induction as authorities. And we shouldn't have any intellectual authorities at all. We need to be able to question and challenge anything so that there's nothing that blocks progress and new and better ideas. Here David's talking about being able to improve things with conjecture, criticism, and testing. And here he is talking about the false authorities of sensory experience and the fictitious process of induction. So, recap. Induction focuses on the senses, not on reality. And scientists predict things that they have no experience with. Change is common, patterns break. You can't just assume that you found a pattern, therefore it will continue. The harder thing is to figure out which patterns are important, not just to find any pattern and assume it's important. And we have to continually improve our ideas. Rather than find a method that will generate great ideas, it has to be generate some ideas and then improve them more, and so on, and make infinite progress. So like, subscribe, and leave a comment if you want this video to do well in the YouTube algorithm. And also, next time I will be talking more about induction.